Welcome to the final part of Module 2. Now, instead of ending this module with another lesson, we're going to instead take some time to test your newly learnt skills and see how you can get on with a little implementation challenge. You can expect a few more of these as you progress through the course, so here's how these challenges are going to work. These challenges are split into two separate parts. The first part is the main challenge. For this, I'm going to give you an implementation task for you to complete inside your own project, but I'm not going to show you how to complete it. Instead, I'm going to show you how the end result should function and sound like for you to then implement the sounds yourself. Once you've finished or you've made your best attempt, you'll be able to watch a second video in which I'll share with you how I went about implementing the audio myself for you to then compare your results to mine. After you've completed the main challenge, then you can progress on to the bonus challenges. These will involve smaller mini tasks that add to what you were able to create after completing the main challenge. Give these your best attempt and see how many you can complete. You can then compare that number with the total number of bonus challenges that was set to give yourself a score and an idea of how well you did. Some of the bonuses will be simple to do and based off of things that we've covered so far in this course, while others you might find a little harder. You may even notice a few that ask you to do something that we haven't directly covered yet in the course. These are there to test your problem-solving skills as well as your initiative, both of which are really useful skills to develop when it comes to programming of any degree. But with all of this in mind, they are purposely designed to be extra difficult, so don't beat yourself up if you can't complete them all. Now, don't worry if at the end of the challenge you find that your script looks completely different to mine. The way in which you design your scripts is completely open, and there is no right or wrong way of tackling these challenges. So don't worry too much about how you write your code. The goal here is to see if you can get the results that the challenge is asking of you by yourself. You're also more than welcome to use any other outside sources of information on top of everything provided in this course to help you. Now, your first main challenge is going to test your understanding of the concepts that we've been looking at throughout this module. The main challenge is to implement an explosion sound that plays whenever a shell fired from either one of the tanks collides with something. This is what your game should sound like. Okay, so pretty simple stuff. If you could do that, then you've completed this module's challenge. If you wish to test yourself further, then see if you can complete any of these bonus challenges. Create your own C# script, and in it you must use the on-trigger-enter function in some way. Randomly modulate the pitch of the sound you implement. Provide in Unity's inspector a way to adjust the size of the modulation applied to the pitch. Create a pitch modulation toggle option for your script component so that you can then turn the pitch modulation on or off from within Unity's inspector. And here's a hint for this one. You can use a Boolean variable and an if statement to achieve this effect. Finally, apply a low pass filter effect to the sound and have it randomly modulate each time the sound is played. Like I said, some of these should be easy for you and others might take you a bit more effort to complete. Before I let you go to give your first challenge an attempt, I want to quickly run through some useful information to know about our game of tanks. First off, you'll want to know which audio file we'll be playing. Inside Unity's project tab and inside the assets folder, go to tanks, audio clips, and here you'll find the shell explosion audio clip for you to use. Next, to find the prefab of the shells inside your assets folder, go to tanks, completed assets, and finally prefab. Now let's select the complete shell prefab and open it. So let's quickly take a look at the components attached to the main parent object of this prefab, which is the complete shell object. We can see that it has a capsule collider component attached that is also marked as a trigger Great, so this tells us we can use functions such as the onTriggerEnter function and gives us a better idea of how we're going to trigger our sound to play. Now you may already be thinking that the first thing you'll need to do is add an audio source to the complete shell object, the parent of all the other objects in this prefab. Well, I'm actually going to recommend you don't do that. Let me explain why. What I'm going to do is quickly leave this prefab and I'm going to play the game. Okay, so what I would like you to do is take a look in the hierarchy tab as I fire a few shells from the red tank. So can you see that the complete shell object has appeared in our scene and then is removed after about a second? So what's happening here is an instance or a copy of our complete shell prefab is being spawned every time I fire a shell. But notice what happens as soon as the shell hits something. It actually changes from complete shell to complete shell explosion. Now what's happening is that the object is not just changing name, but the parent object, which is called complete shell, is actually being removed from the game or destroyed, leaving behind the next highest child object in that hierarchy, which if we take a look back at the prefab was complete shell explosion. Now why is this important? Well, let me explain. You may remember from, I believe, lesson 2 or lesson 3 of this module, I explained that if you attach an audio source to a game object, play it, and then have that game object removed in some way by, say, for example, destroying it, you'll also be stopping the audio from playing. So knowing that the parent object called complete shell is being destroyed as soon as the shell hits anything, it might not be best for us to add an audio source component to it because any sounds we try to play through it won't be heard, they'll just be stopped straight away. So with this in mind, I would recommend you attach the audio source component to the complete shell explosion game object because we know that this object will exist for at least half a second, maybe a second longer after the shell has collided with something. That being said, however, I would still recommend you attach any scripts you create to the parent complete shell. The reason why is because, like I said earlier, we are interested in accessing this capsule collider component because obviously we want to use it as a trigger area. So this leaves us with a bit of an issue. We need to attach our script to our parent object, but we also need to attach the audio source to the child of that object. So with this in mind, because the shells are designed a little bit differently, we're going to need to know how we can access components from a script that is attached to a parent or a child object. Now there are two options we have to do this. The first is to create a serialized variable of the reference data type that matches the component that we're after. Let's say that we wanted to attach our script to the complete shell parent object. This means that we would need a way to access the audio source component attached to the complete shell explosion object. Well, inside of a script, we could create an empty serialized variable of the audio source type, like you can see here. Then inside of Unity, all we would need to do is attach that script to our parent object, attach an audio source to the complete shell explosion object, then go back to the parent object and simply drag the complete shell explosion object from the hierarchy tab into our newly created field shown in the Inspector tab. Unity will then recognize the first audio source component attached to that object and store a reference to it inside of our variable. Our second option is to utilize variations of getComponent. Let's say that we wanted to attach a script to the parent object and that you needed to get the audio source component attached to the child object directly underneath it. Well, instead of just using getComponent, which we've been doing up until now, we'd write getComponent in children. GetComponent in children will look through all of the active child objects of the object you've attached your script to and will search through them until it finds a component of the type you've requested, which in our case is the audio source component. The opposite of this, of course, is getComponent in parent, which will search through the active parent objects of the object you've attached your script to until it finds the component type you've requested. So experiment with both options and see what works for you and which you find easier. Once you've done that, you're ready to give your first challenge a go. So don't forget to give it your best. Check out the following video to this one after you're done. In it, I will explain a method I would use to complete this challenge. And of course, good luck!